This tutorial will demonstrate how to import stream data from a Petro-SIM database. To show you how it is done, the stream data for some flare network relief valves will be imported. Two sections of a plant are considered. These are the oil and the NGL stabilization sections. The two sections have been modeled in two separate cases using Petro-SIM. The stream data has already been exported into SQLite database using Petro-SIM. We will import stream data for 3 relief valves located in the oil stabilization train. First, the blocked outlet sizing case data is linked to the vapor outlet stream in the simulation. Then, the fire case is linked to the inlet two-phase stream for composite vessel fluid properties. Only one case is demonstrated, for the deethanizer, in the NGL stabilization train. The stream detail is located in the subflow sheet, COL2. The relief case data is linked to the column vapor outlet and defines the case for protection against condenser failure. The chemical components used in any stream data imported from Petro-SIM must be present in the flare-tot network. Standard library components that are missing in the flare-tot network will be created automatically on import. Hypo components need to be defined in flare-tot before import, using the same name as the Petro-SIM simulation. In this demonstration, Hypo 1 is missing. We will first create this component before proceeding. On the main menu, click on Setup. Click on the Network Components menu. Click on the Create New Component button. Set the component name as Hypo 1 * to match the Petro-SIM data. Set the normal boiling point to 350 Celsius, the same as Petro-SIM. Change the molecular weight specification to specified. And set the molecular weight to 280, the same as Petro-SIM. Use the Estimate button to estimate specific gravity. This is not the recommended option, but will suffice for this demonstration. Click on OK to proceed. Click on OK to save the component, and return to the component list. Hypo 1 has been added to the component list. Click on OK to proceed. Now we set up the cases in the flare-tot network, so we can import the stream data. This only needs to be done once. If Petro-SIM data is revised, data can be imported again. The oil stabilization relief valves each require a new fire case. The default design case can be used for the blocked outlet. The NGL stabilization relief valve condenser failure case can use the default design case. We first set up PSV1 by double-clicking on it to open the Properties page. Select the Case Properties page. Change the default case name to Blocked Outlet. Add a new relief load calculation case, which will be the fire case. If the design pressure has not been set, the calculation will not be opened, as in this case. You should set this on the System Design tab before proceeding with import, or the relief load will not be automatically calculated on import. Click on OK to proceed. Rename the case to Fire Case. And then click on OK to save the case data and return to the drawing. Repeat setting the cases for PSV2 and 3. We are now ready to import the Petro-SIM stream data. Click on the File menu, and then Import Stream Data. You will see the Flare network sources displayed, ready for mapping to the Petro-SIM stream data. Open the Petro-SIM database by clicking on the Database button. Note that, once opened, the database name is saved with the network and will be automatically loaded when this form is opened again. You can still change it at any time. The simulation case list displays the cases present in the selected Petro-SIM database. The active PFD list displays the process flow diagrams for the selected case. If marked as active, the streams in the PFD are included in the Petro-SIM streamer list. The Petro-SIM database streams that can be mapped are displayed in this list. When a stream is selected in the list, the stream data is displayed in the Stream Data panel. Now select the Component Mapping tab to check chemical component mapping is correct. The default mapping is already correct, so does not need to be changed. Mapped library components, which are already used in the network, are shown with this symbol. Those that will be added are shown with this symbol. These are only added if an imported stream requires them. Note that the Hypo1 component has been automatically mapped by name. Now we define the Flare to Petro-SIM stream mapping. To expand the cases for PSV1, we click on the plus symbol in the list. Repeat this for PSV2 and 3. Deselect the NGL stabilization case so that only streams in the oil stabilization section are shown. Select the Stage 1 vapor stream in the Petro-SIM streamer list. Click on the link icon for PSV1 blocked outlet case to map the Petro-SIM stream to this case. The blocked outlet cases for PSV1 and 2 are then linked by repeating this process. The 5 cases are mapped in the same way, that is, by again selecting the Petro-SIM stream and clicking on the link icon. Now to map the relief valve in the NGL section, we need to select the NGL case. To make it easier to find the required stream, deselect the oil stabilization case. Finally, map the oil stabilization relief valve using the same procedure as before. All required stream cases are now mapped to the Petro-SIM streams. Click on the Import button to import the data. The mapping data can be saved so that all component and stream data links will be maintained when the import dialog is opened again. This means these do not need to be defined again. Click on Yes to save the mapping data. Note that 2-phase stream temperatures may be adjusted to maintain vapor fraction using the Flare physical property module. This adjustment should be small, but ensures the enthalpy basis is the same. Any required adjustments are reported before the import dialog is closed. The data has now been imported. Any relief load calculations, in this case the 5 cases, are automatically rerun so that the revised load to the flare is calculated. Note that required additional data in the source, such as design pressure, must already be defined for this step. If the Petro-SIM simulation is revised, the data can be imported again using the import dialog. This is a one-step process since mapping data does not need to be defined again.